Hey guys, KK9JEF here. I just got my QRP amplifier working and I wanted to show it off. I will go into the technical details of this at some other point, but just some things to see for now. You've got the input and output relays of this amplifier here and a loop of bypass coax between them. So if I want to pass through this amplifier without amplification, I have the option. You can also see the IRF510 switching MOSFETs driven in a push-pull configuration there, and these giant last-minute heatsink additions because I didn't really think about heat sinking when I was laying out this circuit, which is not great. The output transformer there, and the coax lead for the output. The only other thing really on here is the bias circuitry in the middle, and then this little RF sensing circuit, so I don't need a push-to-talk line going into this amplifier. Whenever we see RF on the input, we'll switch the amplifier on if we have power. So for my test setup, I'll use this QRP transceiver, my little ATS4, which puts out about 5 watts nominal. That will pass through this variable attenuator, which is currently set up for about 0 dB of attenuation, and I'll show you why that's even there in a sec. Then we'll go through the QRP amplifier, out the coax lead, and then up into this MFJ Versa tuner, which I'm just using because it has an integrated dummy load and built-in power supply, which makes it really easy to see what's going on. So we'll start with both of these switches in their off positions. So this will be just the output of the ATS4 passing through that loop of bypass coax and directly into the dummy load. You'll notice in these first tests, the meter is in its 30 watt position, which means that instead of this forward power being 10, 50, and 100 watts, it's 1 watt, 5 watts, 10 watts. It's 1/10 of listed power. So barefoot into the dummy load. We see about 5 watts, which is exactly what we'd expect for this transceiver. Now I'll turn on the first of these 2 power switches. You'll hear the relays click once. So now I'm applying the voltage from this 12-volt SLA battery to the drains of those FETs. So this is, say, 13.2 volts nominal, whatever an SLA floats at. I charged it a couple of days ago. It's not super fresh, but I think it's a good simulation of what I would actually have if I were using this thing portably. And I'm also going to switch in about 3 dB of attenuation between my transceiver and the amplifier. What I surmise is that the input to this amplifier is fairly capacitive, just based on its design, and it would be kinder to present something closer to a 50 ohm matched load to this transceiver. So what I really need to do is build like a 3 dB pad into the front of this amplifier, but for testing purposes, I'm just using my variable attenuator and switching in 3 dB of attenuation manually. So we'll come back over to the power meter, and if I key down now, we'll see we're getting somewhere between 10 and 20 watts, call it 15 watts, so 3 times the power we were getting without any amplification. Now we'll go ahead and switch this other power switch here, and what that does is make the power input just to the drains of those 2 amplifier FETs be the series combination of 2 different power sources. In this case, the same 12-volt SLA battery and this 13.8 volt desktop power supply. Much of the other circuitry on board, including the 5-volt regulator, which provides the bias voltage, and of course the power to these 12-volt relays, is still being driven only by a single power source, the first one, in this case the SLA. But the power input to those 2 MOSFETs will now be the SLA battery in series with the power supply. So we're running now at something closer to 26, maybe 27 volts. So we'll come back over here to the power meter, and if I key down now, we'll see we actually go off scale on the 30 watt scale. So I'm going to switch this over to full power mode, the 300 watt scale. So now those meter readings will be fully accurate, and we'll see we get somewhere between 50 and 60 watts of output power when the drain voltage is closer to 26 or 27 volts. So the amplifier has 2 different operating modes. If I was to have only a single 12-volt source, 13-volt source, I could get 3 times the power out that I normally would. If I have 2 12 or 13-volt sources, I can go up to 10 times the power that I would running barefoot with the amplifier. Just some nice options to have. Anyway, obviously there are some improvements that need to be made. I need that 3 dB pad at the start of the amplifier. This thing needs a box. I can't take it out into the field like this. I need real coax connectors on it. There's lots of things to be done. This heat sinking probably needs to be rethought. This might need a Mark II. But in any case, that is the essential functioning of my QRP amplifier.